Okay, we're going to do a quick demo of multispectral coherence, a case study for faults. So as always, I'm Heather Beadle. I run the AASPI consortium at the University of Oklahoma. And what we're going to look at is some fun time slices in the Great South Basin of New Zealand. These are an example put together by Kurt Marfert in 2017. So we've got here our coherence. Lower coherence is shown in black, higher coherence in white. So places that are very similar are showing up as white, very dissimilar as black. And we can kind of see that these are probably some faults and fractures, maybe some channelized features. We've got some synuresis kind of pockmarks going over here on the left-hand side too. So, I kind of pointed out some of these, some of this information. There's some areas that might be noisy. There's some places here where the faults aren't quite as clear. So let's see what we could do to clear it up. So we can do multispectral coherence. So now in this case, we're looking at the same time slice, but we're looking at the multispectral coherence using a simple decomposition where each bandwidth for each component was the same. So the faults are sharper and the noise is reduced. But the kind of downlapping feature we had over here on the left-hand side isn't quite as clear, and that's because it only showed up on a few of the spectral components. So kind of putting the interpretations on there, you can kind of see what I see. As we move deeper in the same data set, now we're about 1.48 seconds. We can look at the broadband and we can see some faults. We can see more synuresis and that downlapping feature. And if we run multispectral coherence, things get cleared up much more. So the synuresis is much crisper, I think, at this time slice, and so are the faults. So you're seeing quite a bit of difference between the two. And then moving down a little bit deeper still, here we've got our broadband coherence. Pick out a few features like channels, mostly on the left-hand side. We've got some faults down on the lower right-hand side. And when we run it with multispectral coherence, we can suddenly see, like, particularly these channels look much more clearer to me, much easier to pick out. Some of these faults are more continuous. And so I'll go back and forth really quick for these two. So here we've got the broadband coherence and then the multispectral coherence. And so hopefully as I toggle back and forth between these, you can see how using multispectral coherence can really help you as an interpreter have a little bit more confidence in what you're seeing and doing. And so here's another example of broadband coherence in British Columbia. So another example from Chopra and Marfert's textbook. So we've got two horizon slices being shown, a few features being picked out with the green arrows. You can see some of these faults aren't particularly continuous, and so we may, as an interpreter, if we don't know much, not be quite so sure what's going on. But when we run multispectral coherence, cleans it up so nice. You can see there's a huge difference. We're seeing a lot more faults, even perhaps some stratigraphic features, like it looks like there's a channel down here. And I'll just go back and forth, and hopefully in these last 4 minutes I've convinced you to try out multispectral coherence on some of your data. Thanks for listening.